Um, Hi, can you hear me? No, not me. Hi, hi. Is it working? Not me. Oh, good. So, is it working? Yeah, good. Yeah. So let's get started. It's 9:30. So, the plan of today would be to finish the second half of lesson 2, and then we will go on lesson 3. I hope we can finish half of it. I mean, half of 3, but let's see. I mean, one thing to remind you, stuff is quiz is already released on the Blackboard. You can do it. Once we do all the questions, you got full credit, regardless of you get it right or wrong. You just have to force you to go a little bit there. After you're done, you should see the correct answer or the wrong answer. If you have theory of whether why you make a mistake, or you don't understand why I have that question, or I may have make it wrongly, then just email it here, and then we'll figure it out. But otherwise, I mean, you recommend to do it when you're free, because once you do it, you get full credit. I think some of you actually asked me when will we release the assignment. My goal is to have 2 to 3 assignments for this class. So probably we'll, after we finish this first set of slides, then we probably maybe early October we give you an assignment. But you're more likely the first assignment will be mostly focused on Python, where I ask you to play Python code and you run the code lab and then submit the code, and then we see how well we do it. And then second assignment probably will be more somewhat some calculation and some Python. And the last one maybe, let's see what we do. I haven't figured it out yet, but let's see what happened. But let's get started. I mean, since we haven't probably you haven't read the slide for a week, so let me quickly review what we have done last week, right? Last week we studied 2 things, right? And then probably we stopped in the correlation part somewhere. But so the idea is to, because the class 1, 2, and then we talk about the data, right? Understand how the data being generated and why we care about that, because that will tell us how to clean the data, what kind of observation you will get, right? As you learn, that is like selecting columns and selecting observations. And after that, then you probably want to look at how the data behaves, right? And there are 2 things you look at: is look at graphics and look at how you look at the summary statistics, right? So the first thing we do as often is we look at the histogram, right? And this would be the way. I mean, remember this code, right? You have panda, and then you have filter here, right? I use LOC to do the filtering the data, and then I pick up the thing, and then I do the price, and this is the B, right? And right, this is how you do the bin. And some of you asked me last time I should put the Python output in the slide, so which I update accordingly. You can look at the updated slides, but there's nothing new, but except that since you want me, then I try to do that. Okay, so it's good that you tell me what you want to change the slides or the way I teach, then I can revise accordingly, so at your benefit. So that's how we look at different bin with different shape, right? And also some of you ask me, is there any advanced way to, or even more easier way to plot? That's what I'll do. Some of them today is called the C-bond library, which is a front-end library built on the top of the matplotlib. So you need to know matplotlib anyway, but I mean, this is the one that actually make the graph look nicer because they predefine certain kind of nice looking features. So you can see it's not terrible, it's similar thing, but we just call it C-bond simple plot. Everything the same. Right, and then you have to call it and then you set the label. So it's slightly different syntax. Slightly different if you on the top of it. Okay, slightly different syntax. But when you look at the diagram, it's not like nicer in the sense that you have all the very nice boundary and everything. Nicer and all the features there. But of course, C-bond is built on top of the matplotlib library. That means that not every feature can be used. I mean, they can use, but the most thing you can use is the refine. So then concern you for our purpose. Okay. And the last time we also talked about how you filter the data, right? I mean, look at the hotel, 3 star, 4 stars, and then also look at the and then look at summary statistics, right? And last time I didn't tell you to do the plot by the cost plot in the thing. I thought you would do it at home, but I'm not sure whether you have time to look at it, so I included here. Again, the same thing, right? It's called the C-bond, but it's very simple. It's SNS.box plot. You can export really nice box plot already. And same if you want the rounding plot, same as C-bond. So in case you are not able to do it, find time to do it in the weekend, then this is I provide a solution for you. This will be the same. Okay. And then one thing that I also didn't do last time, also I asked you to do it at home, is the this density plot, right? I tell you try to do it at home, your time, and I want to show you the answer because I guess some of you may try or may not try. The easiest is again use the C-bond package. We use the then what you get is something like this, same as the one. And finally, that there is one way to plot it without extracting the data is to plot with the data directly. So actually, the good thing about this is you can call the plot and directly pull the data, tell them which X you're plotting and which color you want to change to do. Then you can easily come out with everything. Because why the C-bond is good is because you can see the library is being created for you. So everything is very nice, you don't have to worry about it. So that means that you would, unless you want to control everything, as a first round analysis, in graphics, then the C-bond is a good package because you don't need to worry about a bunch of setup. Just plug it there. That's what you like more the dummy version of the matplotlib. You can do it and speed it in, and it's very nice. Okay. So these are the new feature that I possibly you may miss, but I don't want to bother you with that. I also have added slide that to produce this because I also said, I mean, you may try to figure it out. There's several ways to do it. Just want to do it is I'll use doc describe. If the data set we can series we can doc describe. Can tell you the main thing. Okay, tell you the max, the mean, standard deviation, not skewness, but all but the last column will be given. Okay, and then you can know how to write the Python code to get the last one. And then this code will be telling you that you can start from data and then the grouping, and then you can create data. we can do. But I'm not going to bother you with that. I just leave the code here in case you want to run, but otherwise, there's nothing too special. So I think our focus today will be this one because it's something that is fundamental for the rest of the semester, because we want to establish two things, giving us the idea of how to do data. Because chapter 3 so far is focused on the column, right? You want to look at, say, price or distance, right? Or star or whatever is one column of data, right? But we want to say is different column of data has some relationship, right? The idea is saying that, okay, if we change X, okay, is it how it's going to change Y? Or we see different type of X, is what it's going to predict? Is it going to help us to predict Y? Right? So asking us is how different X will change Y. Right? Some of you may notice we have a big thing happening in our country. It's now the Chinese government is going to print all the money, right? And what will happen? Right? You say printing money is going to help the economy. Right? There's a deep question, right? But we do know that printing money and do all sort of stuff, expansionary monetary policy or fiscal policy is going to change the GDP. Right? Historically, this would help the economy, right? Of course, increase inflation, but as an economist, I will talk about this thing. But IT manager, I don't know, I don't really care or what, but that will be the thing that associated. But if you're IT manager, probably one thing you may aware, Taobao is going to have free shipping to Hong Kong, which you may or may not care. But you can see this. Is it the free shipping is going to change the sales? Right? How does it change? Right? And is it actually the free shipping actually changing the sales at the end? Right? You have to establish that. Right? So that would be the thing. Right? So basically, just want to see X cost Y. Right? The first one is how X change. I can predict Y, but I don't say any causality because there may be Z behind. There's something behind, I don't know, but let's go. But do note that these are the main goal of the rest of the semester. Right? And then you notice this is the thing that we will do for the coming 3 to 4 weeks. The last 2 weeks we'll do this. Basically, what we do is the rest of based on what we are doing. And right, this is the first goal will be like we have time series model, with regression, we have machine learning method. So basically goal number one. And goal number 2 will be a kind of you need more technique, you need say regression discontinuity, difference regression, panel data, experiment, this kind of method to get number 2, right? Goal number 1 is the first step, and goal number 2 is what we want, right? Because goal number 2 is the thing that you want to make business decision, right? You want to say suppose whether Alibaba is going to say right after the experiment of having a right free shipping in Hong Kong, is it going to work it? Right? They spend $1 billion on this infrastructure to have free shipping. Is it going to work it? Right? Is it going to be good or bad? We don't know, but there is something that is going to be done. Okay. And there are 2 ways to do it, right? We want to have a scatter plot, bar chart, or histogram. There's a graphical method. And then at the end, we want to look at the numerical method, look at correlation and covariance. So two steps. Okay. So remember this example of the management quality data. If you forget, but just a quick reminder is this is a big global survey. They send a lot of expert MBA students around the world, go to the site and look at talk to the manager, see how they're doing. There will be 18 different area scores. Each area will give 1 up to 5, and the management score will be average from 18 score. So the main question is now we're going to ask is how management scores with the firm size, right? Is the firm getting bigger, having higher score, or higher score lead to a bigger firm? We don't know, but we want to say are they going the same direction, right? Because in theory, in economics, right, you know, either is possible. Because of, say, a small firm having a good management score, that good firm, then we grow, right? So good score lead to bigger firm. Another way around is possible. Big firm, having bigger business, having better scale economy, can hire better manager, right? And then that's why they have better score. So it's not clear that which cause to which, right, from economics. But we can see from theory, right? We can't tell, but from data we can tell at least whether these things go together. And it's the first step to see whether actually one causes the other, right? And that would be the idea, right? If actually larger firm have better this, right? Then it's very simple. Just combine law firm, right? Just make effort to combine firm together, right? Make more statement applies, right? Government encourage firm to merge, right? That would be the policy goal, right? So that would be the idea. Or if the causality go from here to here, then public government should subsidize firm that actually doing better, right? So that would be different policy implication. Of course, the same would go for business decision, right? So that would be the case. Now go back to this example. Probably you still recall, let's say, many year panel data that focus on Mexico, 2013. Not too small firm, not too big firm, and up to 300 firms. You want to look at how the management score with the firm size. Okay, and if you still recall, the data is done from there. I mean, I'm not going to. This is how you filter data using LOC, and then you get this data here, and this is what you draw, and you have that, and then you draw this as well. Okay, and this is what you get, right? This is what you do in the previous chapter 3 of the book, right? Just look at the individual data, right? And then this is how you do the MP mean, standard deviation, and that, right? And what you left is, as I said, we want to look at whether the firm size related to the management score, and because 18 score, we take up one particular measure called the lean management score. And that means that whether the company is bureaucratic or not, is there a lot of paperwork or less paperwork? Lean means that it's like very easy, right? It's lean, it's fair, lean, right? So the first thing to do, right? Of course, you want to group them into 3 groups. You don't have to group them, but the book suggests you divide them in group. Okay, that makes things easier to see. That they group them into 3 different groups and then look at the mean of the management score. Okay, turn out to be small, medium, and big. The score is increasing. So this is the first thing you do, right? Look at the mean, right, by group. The second thing is try to see if this the data with the stack bar chart, which we actually do last time, right? Is use M.Phil and I'm not going to repeat the code again, but that's to group them, and then you calculate the average, right? Did we stop here sometime? Is it right? Did we stop here, right? So I think that is where we stopped last time. Let me check the code. I think we stopped here. Right, this is the last time we stopped, right? Just a quick reminder, right? Just the code again from the beginning, because I want to make sure that everyone know what we're doing in case you are missing last time. So we start from this NumPy and pandas, and we download data and you read it. Okay, so I think you should be able to explain every single code and then focus on filter data. Look at Mexico, only particularly here, not small, not too small firm, not too big firm. Okay. And then the next code is I try to look at the score and plot them out. And then I look at the employment of the firm and plot them out. And look at the mean and median. Just look at this is EDA, right? Exploratory data analysis. Then I look at, because I don't want to look at the a firm size directly, so I divide them into 3 different groups. And you may ask me how I do that. No, I didn't do it. So for the book do it. I just do it. I mean, you don't have to be 3 groups, you can be 4 groups or 5 groups, even 2 groups. There's no particular reason why you want to focus on this particular thing. Usually when you go to work, it's the boss tell you how to look at it, or historically how people do it. Of course, you can be innovative, but that is what it does. And I completely understand where it's trying to say whether 1 or 2 or 3 depends on the size. If less than 2, just 1, and then so on. You do 1, 2, 3. I think we explained this in great detail last time, so I'm not going to repeat myself. And then what I do is I only focus on these 2 variables, right? The firm size and the mean management score. So then that's why I filtered it out. Okay. And then what I'm going to do, right, is I want to calculate the relative score, so relative grouping, how people, because what we want is to plot this diagram at the end of the day is trying to see, right, fixing different size of firm, relative percentage of the score they get. So I need to get a percentage of the small firm getting score of 1, right? So I need to get several data first. I need to get total number of firms in each group, which is I do here, right? So I want to group them by each group the numbers, and then I want to count how many firms within the same group. And I put a count how many of them. And that would lead us to this. I think if you have that, is the code is like that, right? It's counting is within each group. I generate 2, right? Because I just count how many in the same group, right? And then after that, I calculate percentage, which rely on the count over the group count, which is the code is here. Oh, sorry, I have to calculate this first. The second is I do is within each group, I want to calculate the group count, which is the code here. I think we explained. I mean, oh, sorry. Sorry, this is I'm counting for each group by this, right? So for each combination, I counted how many of them, and then instead of grouping the whole thing, I just group by this guy. So I collapse everything here, calculate the sum. Okay. And then I have this. Okay. And once I have this, I do the dividing. Okay. And give me the percentage. And once I combine, this is the data I have, right? We stopped here last time, right? So then we need to do the plotting, okay? How to plot this data, okay? So this data is not easy plottable because this is the way that the data looks like. So it's not really nice enough. So let's see how we are going to plot this out, okay? So to plot this out nicely, in order for the data to understand, we need to define them to be categorical data. Because by category, the data know how to change color of things. So you define them, you call the categorical function. And I will declare both of them to be categorical. So both the mean measure and the also the size, firm size, is also categorical. The same thing here. Right? We just change this and this here. Right? So what I do is I declare categorical and declare them category. The category because I want to follow some order, right? Because category, but I also want, say, 1, 2, 3, 4, 5, right? But I also still want 1 to 5, 1 to 5 display in order. But otherwise, you may go to 1, 5, 4, 3, 1. Right? So what I do is I sort them, okay? And I use the function set. Set means that I look at all this data set, I take out all the duplicate, right? I 1, 2, 3, 4, 5, 1, 2, 1, right? All the numbers. I look at the set means that I just take out the unique item there, the set function, and I sort them, right? I sort them out, and that will be the category. Okay. So let me copy this guy. Do it here. Okay. Oh, sorry, I should have. And then I also want to do the same for the next one. Okay. So I have to start from the beginning again. So here is that. Because I want to run everything below, one of the easy ways to click this guy and runtime, I run after. So if I click this, I run after, it will run everything. Okay, that is some tricks that you don't have to click everything. So you keep automatically run every line down there quickly. So it's done. Okay, you can't see anything because they just do the grouping. They just declare them categorical here. So I just do the same. Okay, once I do that, now I'm almost ready to do the plotting. Okay, so two more steps before I do the plot. First is I don't want 1, 2, 3 to display. I want small, medium, large. So I just do the dot replace. Okay, using this dictionary idea, just replace and tell them this variable I want to do this replacement. Those 1 becomes small, 2 become medium, 3 become large. I do that. Okay, this is the first step. And then so everything will just work, right? Now the next is slightly a little bit more interesting. Okay? This is creating a pivot table. And what we're going to do is to make sure the data looks nice before we plot. So what we do is we want to create a two-way table. Okay? With the rows are the size, okay? Small, medium, large. And the column are the mean score 1, 2, 3, 4, 5. And the number there will be the percentage of the firm. Okay, then you can plot. So let me do it, then you will probably let me copy this whole code. You run, then you see what actually I am doing. So once you run this code, okay, you will see what I do is I would have a two-way table, a standard pivot table, right? I have a large, small, medium. Okay, and maybe I should say true here because otherwise it become doesn't seem to be good. Maybe the thinking. The reason I do true is because I want oh, it's not changing. Whatever. It should be small, medium, large. And then once I do that, oh, it's the lean. I think it should be both for us. Because I want to from small to large. So let me go here and run again. And the table looks like this. Okay. Small to large from 1 to 5. Okay. So this is the table we want. Okay. Just make sure you get this table right. And then I think you can then after you get this one, then we can do the plot. The plot will be very simple. Right? But this is the graph that this is the table we want, because once we have that, we can have, right? So the idea is this is the row, column, this is the value. So that would be the way you do the pivot table. If you know Excel, pivot table the same, exactly the thing, right? So what we're going to do is to do the plot and bar chart and stack it. So that would be this is the way we do the plot. Okay. If everything's all right, then we can just plot. Okay. So this is exactly what you see here. All right. You can see this document. But let me have 10. I think we should have 10 seconds for you to try to plot this graph. This graph is very useful to solve this. So that's why I took the time to do this. The scatter plot may not be good enough all the time, because we may. The good thing about compare this to scatter plot you will learn later is because this one works for the group data. Right? And other time the data group. Right? You may have, if you work for IT, right, this may be the age group, right, or different city, right? You probably want to show relationship, right, between things, and this is often very useful. Like this. Do we? That's so important that I want to consider it. People have no problem with the code. I can see many of you have the graph done. Just walk around to check if you have any issue. Or maybe a little bit slow, but I just want to make sure that no one's left behind. So that I can plot this one without any big issue here. Okay. Now, what I want to do next is, because of that, right? Then we want to plot a two scatter plot, which we often more see in the data, right? Because usually you will see the scatter plot first, right? But I don't know why the book would call the scatter plot first. But anyway, we just follow the book's idea. So let's plot the two other plot. Okay. So we'll do the scatter plot, which amazingly simple, right? Compared to histogram, you just plot scatter. So basically, you do this. Okay. Just the same thing with histogram is this, right? We call X and Y and do the scatter plot. That is the most simple thing you can do. Okay. And if you can do that, of course, some of you who know Python, then will notice that my code is not the most clean or most beautiful code, but I think it's the most easy to understand code. At the first round you learn, but probably when you learn later, then you see my code is not the most efficient, most beautiful code. But I think it's what the code is the most. But later you do better code. But you can see this is a diagram, right? And this diagram doesn't seem to show that we positive related. Right? Look at this diagram, right? It just seems to be a lot of dots are here, right? A lot of here, right? Seems to be there's some trend slightly, but if you have to think there's a trend, I don't see it, right? Because this thing are so complicated, right? So, but if you still need to do something, so the book suggests that, which I agree, is you don't look at the scatter plot from the raw data. Rather, you group them into groups, 10 groups in our case. 3 would be too little, but group them into 10 different groups. And with each group a similar number of data, then you can try to plot that. Okay. Okay, that is the book called Bin Scatter Plot. So what you're going to do is roughly divide into 10 bins. Okay. And of course, almost equal size, try to, but not try to do that. Is look at data from 1 to 10, top 10%, so forth, right? The bean is not equal size, but try to do that. And then you plot the scatter plot again, okay? You group them in 10 different groups and use the average of each group as the data point. Okay, that's what we're doing, okay? So what we're going to do is use the function called Q-cut on top. Basically, you divide the data by the firm size and divide it into 10 different cuts. Okay? And right, you know that we are treat X and Y differently, right? We're going to do the Q-cut on the employment, the firm size, but not the Q-cut by the score. You may ask how to make decision. This because there's no particular reason why we do that, right? But the key here is we want to group by firm size, right? So that's why we cut by this. Right? We're not grouping by score. So that's why there's a reason why we divided in 10 groups. And what we do here is try to look at these 10 groups. So they look nicely. So that's why we are doing the B.B.A, right? Exploratory data analysis, right? Look at 10 different groups. What the mean maps, are they similar or what? But that is what we're doing here, right? I think now it's very easy. I just basically, here what we do is I fill the data, look at these two columns, and group by the beans, and then look at the data, okay? And see whether there's some special thing goes on here. So that's just what this code is doing. Just copy it, and then you can just do it. You will see this code, right? Divided into 10 different groups, okay? And we try to get similar size, but we can't. But anyway, just try to be similar size here. And we have to match me. You have some idea what's going on here. It seems to be okay, but not too crazy. Everything seems to be in good shape. Then this is what the Q-cut does, okay? And the next is, as I said, we have 10 groups now. We want to use the mean of each group, right, to do it. Okay? So that's why we are replacing the group by the group mean. Okay. What I'm doing here is look at this again. The groups are an interval here. So I don't want this to be, we're going to plot this, right? So we want to replace this side. Okay. The row ID, mean this empty bean, I want to use the mean to, okay, because this is summary data, right? I want the data to replace everything by this one. So what actually I do in the code is I look at data set, I replace, okay, this by the summary, right, of the mean, and to take because I want to map it. Okay, the map it because all the data set, so I want to predict is to do the mapping. Okay. So if you look at this, okay, again, if you run this code, oh, sorry. If you run this code, look at the DF as well. Look at the very last column. Okay, I replace everything, right? Predict means because I want to map by pixel. It's the same row, right? It's the same group, but you map by pixel. By mapping. That's why I did predict. Why predict? Because remember how the replace work. The replacement is to give the dictionary. That's actually we have been, if you're aware, those Python, we still remember. That's why you have to use predict to do the replacement. But I don't want to go to too much in terms of the Python, but you know why we have to do today. Hopefully that makes sense to you. Okay. Now, what we do is to create summary here, okay? Because you can check that again, okay? By group, okay? Now it's a better summary. So you can see I just replace this. Okay. That's what I do, just to demonstrate that what I have done. Okay. So replacing the range, the group now is called the mean of the firm size data. Okay, so that is what I'm doing. So I hope that now makes sense what we're doing. Okay. And once you get this idea right, what's left is now I have 10 groups. Now all the groups I have the mean of the firm size, right? Or X is ready, but Y is not ready yet, right? So I need to look at, group them by the firm size. I want to calculate mean of their scores. So that's what I'm doing. That is what I'm doing, right? I have the data now is all the data. But now I tell each entry, I tell them which group mean they're in, and then I calculate the average of the score within the same group, right? Then I have all the data ready, okay? So if I run this, you will see that I have 10 groups, right? Just repeat, right? Now I group them by the firm size mean. I want to calculate within the same group. I calculate average the management score. Okay. Once I did that, right? This is the data I have at the end, right? Because this, in the end, I want to plot this in a scatter plot. Only 10 observations, which is the first group, the mean of the firm size, the mean of the employment. So you can see it takes a long while to plot this, but let you think after we do that, you think it's worth it, right? So now what I do the same thing, right? I take the data set, I plot X and Y and plot it. Okay, there's nothing new in the code here. But let me plot it, and I stop a little bit for you to follow. So this is the plot that we want. But let me stop by 1 minute for you to make sure that you can follow how to plot this bean scatter plot. You can see the procedure. What I do is I first cut them into 10 different groups based on the group. So based on the firm size, okay? And you have to replace the group by its group mean, okay? Right, and then I base on each group, I calculate average management score, that end up with 10 data points. And I put that in the scatter plot. I hope that is clear what we are doing, because this is something that you should do when you analyze the data, right? Of course, this data set is very small. But as IT manager, you often have a very big data set that will take some time, but at least you can see from this data set, right? At least from the small to big firm, it's just like a jump in the management score, and here also have a good jump, right? It's a nonlinear relationship. So at least from this diagram, you can see that they are positively related. Right? So that would be the goal we have done. Is that okay? So, and So now we learn three different types of tools. One is just stack bar. Second is the scatter plot. And the next one is beam scatter plot, means the group scatter plot. The third way and the fourth way is called the beam box plot and beam bounding plot, which means a grouped box plot and grouped bounding plot, which also when you saw and also come out, you see a main report as well. Okay. So what we're going to do, okay, it's the same, right? I divide them into three different groups using M.Phil, same you have seen, right? And also declare them as categorical, all right? So this is the same code as before, but I just do it here. I mean, I don't know, I do it again, but I just do it. Okay, the same code goes on. Okay. Now, if you still recall, when we do box plot, we have the C plot, right? And C plot, I do the box plot. Okay. I want X is the grouping measure score, and I have data here, and then I have the color. This part doesn't really matter at all, but just make the color look nice. Okay? This is coloring based on the group size. So then if you have this line, that means that the box plot of each plot later you see a different color. This is coloring. Okay? And this is just the label, and that should be straightforward. Okay, if you do this, so you should be able to see this diagram here. Okay. Maybe I should choose true. Okay. True will give you the newest order, then small to big. You can see not exactly very clear, but still you see some going up direction, right? But that has much more variance. But at least that you can see, at least large is much better than small. Medium is slightly unclear, but you can show how they relate. Let me have 10 seconds. And once we have that, I hope that's okay. We go to the last plot, is a bounding plot. The same thing, but instead of box, wow. So everything the same. Then you just copy that line. Okay. Hopefully that after the first 45 minutes of our class, you learn all the graphical way to show the difference in data, how they're related, right? The good thing about this is a scatter plot is here are different management sizes, ordinal data, right? But this need not be anything related, right? Can be Shanghai, Hong Kong, Beijing. They have no order. You can just plot it, right? At least you can show how things are different. So that's why this kind of plot is very useful. Right? Although here I want to show relationship, right? But you may probably want beyond that analysis as well. All right. So after the break, we will talk about a quantitative way to tell us how two different columns are related. Okay. And this is something also to see. And this is the first step to quantify the relationship between the two, right? And if you learn, you still recall undergraduate statistics or econometrics, this is the beginning of the regression, right? Regression is to look at correlation among many variables. right? The basic linear regression is going to look at correlation in a more systematic way. Right? So this is baseline of regression, right? Once we have correlation, then we regression, and once regression, then non-linear regression, that's a machine learning. Right? Or the time series method is also related to that as well. So that's why everything starts from here. But before we go to a more difficult journey, I know many of you don't have enough sleep last night, so let's a break. You have time, then you're not that sleepy, then try to do a survey during the break so that I know whether I'm too fast or too slow, or you have something to share. Please do so. So that's a break of 15 minutes. In the meantime, I go around to see if there's any question, and we'll resume at 10:45. So I go around to see if any question, but have a break. Yeah. 因为它在那个分类展示跟，比如说里边在一个小类的话，这个才不好，这种过程，这可以再多一点的一个对对对，所以它有它的，但是我没办法讲的，没有这种比例的，日本那边我的确是被改，日本那边，因为它那个东西是很 generic 的，比如说刚才说 step up 一个，那个可以一个，就是那个它还有那个数字。step up 的形式，比如说你这个 step up 正在 step up，所以说这个点它就每个不一样的一个要求，它加一个多少。它的笔记本都不是好像电脑刚才下一节课就下一节课，然后这里你看， Hi, not working. Hi. So let's see what you want to say. Yes, you can go to the Wednesday section, which is items here as well. If you can't attend class, because we need to make up 2 classes. One is due to typhoon. The other one is actually M.Phil. He's in Macau at the conference, so he will be. You can attend. If there's spot, you can stay here. You can go to the Wednesday section. But I'm not so sure whether you have enough computer. So if you join, then you probably have to bring your computer. I mean, you may have to squeeze it or them, but you can also do the Zoom as well. Okay. Subject to the availability of the space. Why density is true? The density is true. I think it's here. So the question is, why this one? So you have a density is true. I didn't show the graph, right? Density is true means that everything is plotted in relative frequency, right? Because you can plot the graph by percentage, the height, or by frequency, number of frequency. Okay, so maybe put it this way. I think this graph is the easiest to see, right? The data is same data. If I have true, then we got this one for us. If I don't have false, we'll describe. So then whether this or this is, you decide which one to show. Sometimes number is important, they show number. Sometimes percentage will do trend, if this will show this one. And when you compare different data sets, sometimes it's the best one for the trend. But if you want to do actual number, this is what you do. I hope I answer your question. Why to replace the mean? Okay, so the question is here. I guess why I need to do the replace with mean. Okay, I think it's 10 group. I guess the question is why I do this one, right? Is remember before we do this, look at this again. Okay. The data before this is the mean actually is give you the range, right? Because I want to plot this, so I need to replace this with here. Okay? So that's why I do the two, which because this is the original data is like this, right? So what I do is to mean is I replace this, right? Original is like this interval, I replace it with the mean. So then I can later plot, because I want to only plot the data points which mean of the size of the firm and management score, right? So that's how I replace that. And why to take, because replace is using dictionary. So that's why they export the dictionary out. I hope that is okay. If you still don't know, ask me again in the second break Q&A. Okay. Can easily follow. Let me repeat a little bit briefly what we are doing. Okay. So what we have done before the break is we try to tell you how to demonstrate two columns are related. Okay? And we actually demonstrate actually many ways, actually 5 different ways. Actually 6, and as you know that. But the first way we do is to show you that you can group them and calculate the mean. Right. That is actually, we do that, right? Actually, this number, right? You can group them and then do the average. Okay, I think you should know how to do that. And I group them to 3 groups, right? And then you can calculate the score and the mean, right? And then you calculate this diagram. This is the diagram to demonstrate that, right? The larger the firm is, then actually the more likely the higher score. This is a stack bar chart. This is the first thing, right? And the second one is we do the scatter plot, right? Which is just try to put the data into the XY plane, right? This is the size, and this is the management score, and each form represents one firm, right? And this is not clear enough, so I want to group them into 10 different groups. So basically, I look at top 10 here, right? The first group is averaging this become the new X, and averaging this all the data here of the Y, and then the 1 point. Okay, how I do that in Python? First, I divide this into 10 different groups. That's Q cut 10. Okay, but the Q cut 10, the trouble is they didn't use average. Of course, sometimes you use median anyway, but they give the interval. So the first thing you do is for each group, you calculate the mean and replace the mean to this group interval. That's why I do is to mean thing. And then next thing is I collect the data by group. Right? Look at each group. I calculate average score of the management score. That is the number there. That's how I group by and aggregate. So that is how I do here, right? I group by each group and calculate the mean, right? So end up with mean of each group. Okay, so that's how I draw this 10 different means set of form. I hope that is clear. And then the last 2 steps is I try to do a box plot, right? Which is group them by group and plot. It is very simple. There's nothing very deep here, right? Because just by group and do the box plot. So there's no need to do all the complicated calculation, right? There's some group already there and just do the box plot, right? And you group there, then you do the volume plot. So there's nothing very difficult here, right? The only thing is probably you see too many code, then your mind will explode. It's normal. When you already simplify, you try to look at the code profile of the textbook, look at the GitHub, the thing is like even more terrible. So I try to already reduce your thing, but I mean maybe I should reorganize the slide a little bit, but I hope now it's more clear. Do we need to know the every detail? No, I don't think I would try to ask. No, I don't think I would try to ask you the detail like this, right? That would be not very useful, right? I try to ask a question in a useful form, right? Not really asking you this kind of thing. Maybe I will ask you, hey, what does, yeah, this is too kind of little too complicated, right? How I'll be asking, I give you the code like histogram or scatter plot, this kind of basic thing, right? There are one simple very not. It's not programming class, right? So don't spend your too much time on understanding every single option on it. But the basic thing how to put histogram is good. Then the way I test it, maybe ask you, you should be able to do it for your project, right? That is the way I assess whether you know it. But for the exam, it will be something basic. That's something I should ask. I mean, last year, even I asked a basic question, not everyone knows how to answer. So I don't think I need to make the exam very difficult, right? So don't worry about that. Anyways, open book, right? So don't worry about too much. But as I said, I'm not trying to trick you by making very weird question of those. No, don't worry about that. I hope that make you feel happier. But that's not my intention to make you fail, right? So just try to see who is doing better. Oh, so what person think it's Monday? Just make sure that this afternoon you still have a class, right? It's not Monday. Yeah, that's good. Whether we never have consensus. Reset. Yes, Seaborn. Cut SNS library. Okay, so everyone seems to keep us no. The speed is okay. I mean, maybe there somewhat people say I'm okay. I try to see what I can improve. What does that mean? So I think this is a good one. If you have P more than 5, then you return P less than 4. So that's what we call P hacking. If you do it, you run many regression until you get P is less than 5%. The P thing we will learn next class, or maybe. Never going to run around and desert you. Oh, I think this is a. If you don't know, this is the very famous internet song. Part of the lyrics where if you watch this video, I mean, always scam you. Oh, here we have same thing. Oh, there is a thing you have to be very careful. You have to drink early enough. Okay, if you understand the mechanism of the coffee, why it works is because in the brain, there is some cells that make you feel tired, right? And coffee is the caffeine is trying to block that thing before you get feel tired. So if you drink late, it's not going to work. So if you early drink the coffee, block that, right? Then the tired chemical can go to your brain. So if you are already tired, you drink, it's not very useful. You have to drink before you get tired. Okay, just like when you already getting very fat, do some exercise is not helpful. Before you get fat, you should do exercise. So that's what I suggest. I mean, before you get the age of like me, exercise may not be very helpful. But you're useful anyway. But like you guys are very young, so keep exercising. And then you'll be better. right? So if coffee doesn't work, then probably you should drink tea. Actually, tea has a even stronger. Or if coffee doesn't work, then you should do espresso. If not, espresso doesn't work, double espresso. If not, then triple, then it should work. But remember to drink earlier than okay. So the last one, don't worry, is something very simple. Okay. I think you have learned it in the graph. Okay. But just to tell you again, right? And before we tell you 5 graphical ways to demonstrate how they're related, but we can do a more numerical way, right? Because everything we try to demonstrate is either graph and also number, right? Undergrad, you learn actually 2 ways to demonstrate how things are related. The first one is called covariance, okay, which we will tell you graphically what it means. The next one is correlation. Okay. And let me explain what's covariance. The formula is very simple. You just take whatever value the data have minus the x mean and y minus y mean, and then product. And for each observation, do that, right? Over n, then it's the covariance. I add some slide from my undergrad class to demonstrate that case, but if you have old version, don't have that, but it's the same thing. There's nothing new different. So look at this diagram. This diagram has this number data point, okay? And x bar, the mean of x, is location where the distance to the left and this to the right are equalized, same as the y, up and down. Okay? And I draw it to demonstrate when the numbers are here, okay, the xi minus x star is positive, right? Because this is bigger than this one. But this one is negative, right? Because x is below the mean. And for this point here, y is above this. So these 2 entries are positive. And here, these 2 entries are positive, right? Positive multiplied by positive is positive. Positive, negative multiplied by negative is negative. Okay. So for data entry here, the numerator part is positive. Right? And if the entry are here, they're negative. Right? So you look at this again, you add all this thing up, right? So it's asking, right? Positive means that if x is above the mean, y is above the mean. If y is below the mean, x is below the mean, right? Whether they go the same direction, right? Negative means that when x is above the mean, y is below, or when x is below, y is above. So they go in different directions, negative, right? So look at overall the data, whether the data x and y go the same direction or not. Positive is yes, negative is no, right? The bigger, they're more likely to go in the right direction, right? So whether that is what the covariance measure looks like, right? Right? That's why you say they're positive related or negative. Right? And this is not usually the measure we use. The measure we use usually is we scale the version, which is divided by standard deviation of x and y itself. Why we do that? Because when divided, then you avoid the problem of scaling. As opposed to multiply, you measure x instead of centimeter, you measure by meter, then this is becomes smaller. But you divide that, then everything scale equal. So this measure, one thing nice is doesn't matter whether how we measure. But the most important property of this is always is 1 to negative 1. Right? So that is why it's so useful, because our mind can handle 1 and negative 1 easily. Right? Because when the covariance is 1 billion or 1 trillion, I'm not sure what was I get. Right? If covariance is 100 or covariance is 200, I mean, how to understand that, right? But if I say correlation is 1, I immediately know they're on the same line, right? Negative 1 is negative 1 is negative straight line. So that means that the graph is like this, right? If positive 1, everything very nicely on the same line, you can draw a line there. If -1, it will be a negative line go downward, right? If 0 means that you can't redraw a line, okay? Any line is possible. 0 means you can draw it this here, you can draw here, you can draw here. It works. Means that they have no relation. I mean, it's random, more or less, okay? And positive means that they go on the line, but not perfect, but you can see they're going in up direction, right? Negative means negative direction, okay? So that means that that's very simple. The correlation coefficient is trying to the first step to do it. As I said, when we run regression, it's basically drawing a line, right? But we will learn that 2 weeks later. So let's go to Python, okay? So this is how you calculate correlation coefficient on covariance is using step package. If I have two lists of numbers, I want to calculate covariance and correlation is with statistics of covariance. Okay, I mean there's nothing very deep here, but I just copy and run it in case you would want to know, right? I just do one by one because this is covariance is 4, correlation is 0.9773. So basically, it's almost very strong, right? So it's positive, right? 4 doesn't carry a lot, but this 0.94, 0.97 is a lot, right? They're almost on the line. So okay, I hope you can run this guy. If that's okay, then probably we want to go to the data, right? Because before we do that, let's do a typo here, sorry. Instead of statistics, actually, numpy has also have that, and that actually is more convenient. Okay? So we as import numpy as NP. So I think you should know now, right? X and Y. Then this one actually would produce a covariance matrix. If you learn statistics, it's going to be like this. Actually, what they're doing is XY is produce a matrix. This covariance, what they do is like this. Okay. Then they would have a 4 number here, 1, 2, 3, 4. This number is covariance XX. Okay. And if you look at the formula again, covariance of itself is just variance. Right? Covariance X is just variance of X, right? And this will be variance of Y, right? Because it's covariance YY, right? And this is the guy we want, right? This is covariance XY. Okay. Of course, this guy is same, is symmetric. So this covariance YX. And either you can use 0, 1 or 1, 0. No difference. Because 0, 1 this guy, 1, 0 this guy, same thing. So, and here I have true or false. It's just saying that the variance whether you divide by n minus 1 or divide by n. Okay? If you have true, then it's divided by n. Okay? If you have n minus 1, it's the sample one. And correlation could be the same thing, but instead of covariance, I have correlation. So yes, is that okay? Let me copy this one. Don't remember it's import numpy as NP here because I have typo, but I think by now you shouldn't be so if you don't use this one, you have this guy, I suppose, right? You give you the matrix. So give you the matrix here. This is variance X, variance Y, covariance. Okay. So that, and as as we said, right, very often we actually don't care about the covariance, but rather the correlation coefficient. So this is the thing that you always look at, right? Coefficient, and then I look at it. This is the one we get, right? Correlation coefficient by itself is always one. So this is simple statistics. I mean, you have learned it in your undergrad, I hope, but you probably may not remember that, but that is not something too difficult, right? I hope that is okay. Is that okay for this one? Is that okay? If okay, then we go to a little bit more fun because we want to take it to data, right? Otherwise, we are not interested this thing by itself, but how to apply data, right? Because this is a we apply class, right? So you really want to show how to do this covariance SB correlation. That's how I demonstrate this. Okay. How do we do that? Okay. Correlation coefficient, convenient part is independent package already allow you to do the correlation coefficient. Okay. Either there are three different ways. Okay. Probably if you want one column, already the other column, then solve. Right? This is a vector. Or you can reverse it the same thing. Or you don't like, you can call the two things out and dot correlation. You give the matrix. Okay. So let me show you one by one, maybe one and the third one, so you can see what's going on here. So let me show you this guy first. So if I do this, okay, you give me a number showing that as we expect, the firm size, the management score have correlation coefficient on 3. Right? That's something we want to see, right? They are closely related, right? The larger the firm, the higher the management score. So that is something we want to say. Right? This is the first thing you know. And very happily, this is the number we're getting, okay? And as I said, you not only want this, but sometimes you want the matrix, right? Then you can create that. So this is right. And some of you ask why we won't have a matrix, because sometimes we want more than one, right? We can show, say, mean one, I think. Right? If you want more than one, you can show a matrix, how things are related. So that's why you can see matrix is important, because you can do all the pairwise correlation. Like difference is score, one particular score, right? Management is the average of a case. So you can see that right. That is how we calculate that, right? So demonstrate how they're related, right? You can add as many as you want, right? I think if you is that clear what we're doing? Okay. Now what we want is to actually showing this thing, okay, which more fun is this overall is 0.3, we have that already, right? So look at the textbook, actually they tell you want to break down by industry, right? Because they are thinking that is it not due to firm size, but rather the industry is important, right? So that's they want to do is look at particular industry, then they want to look at the correlation, right? It turned out to be look at the food doesn't really matter, right? But others much higher, right? So that's the one way to do, right? So how do we do that? It's fun because you would do something crazy, but don't worry, it's not something difficult. So this is what they're doing is there's a column called SIC, Standard Industry Classification, which is a number telling you which industry the firm is from. Studies that any standard US data. And SIC. In China, they also have SIC, but I think a different code name. I forgot. There's some way that China data is being done. But saying that, okay, these are the food industry, let's say 21, if 22 and 23 or 31, then you would call textile, so on and so forth, right? So basically, just the way you do is .RLC create a new variable called industry, and based on this, you call that. Okay? So it's somewhat like anywhere, okay? And you ask me why the book do the same thing in different ways. I don't know. Probably the author of the book asked different hours to do it. So different hours have different type of writing code. And I don't want to make major changes to the code that provided by them, because otherwise I have to read the book. To read their own, that could be difficult. So that's why I just keep the code they're doing. If I would try to write that, I'm not writing this anyway. I just follow what they're doing. Okay. So that is the way that they divide it into different things. Just clean the data. Okay. Since it's just normal cleaning, so I just copy and paste. There's nothing new to learn here, but I hope you understand what they're doing, right? So basically just mapping all the industry number to industry variable. There's nothing new here, all right? So suppose if you are not convinced, what's going on? Okay, and then once you run it, then you say df, then you will show you the data and look at last column. This what we industry telling you that which industry then, right? So basically, it's mapping from the SIC to this. Right? This is a standard way to clean the data, right? Because you record the data is where company is done, right? Once we did that, now the two steps before we're done. First is we want to look at how many firms in the same industry. Why we do that? Because this is the last column here. Okay. So that's why they do the value count, right? So we just replicate what is being seen from that table. So this will be the last column. Okay. And very final thing here is you want to calculate correlation, right, by industry. Right? So that's why we group by industry. Right? And look at this score and do the correlation. Right? Because for each industry, you want to do correlation. So you can see a lot of time you do a lot of group by. And turn out to be when you do data analysis, this group by is you always do that. Almost always do that because the data always you can group by something, right? You don't just care about the raw data. We often when we do our high model analysis, always group by is so commonly used. It just hopefully you would feel normal to do it. And here correlation. Probably why I would do that, right? Okay, right. Because this guy will be very big. And let me do it, and then you see why I want to do that. Okay. Let me just copy except the ILOC. Okay. You will see I have a big matrix there. Okay, once let me run this line. Okay. Group by industry and there's a topic. Okay. And all right, so by each industry, I have a matrix, right? But you know that this is symmetric, so I don't really need this three thing, right? I just need this number, right? So that's why what I do is I would use the index location. What I do is I only need every other 2 rows, so that from 0 to use every other row. Then I need the last column, right? This row, this is column, right? Last column. And when I do that, then you will see what I have, right? You will see. Is I only get this number, right? Because this every other 2 row, right? 1, 2. So that is why I have this code. So that's why I only need this one, right? Another thing, if you want to look at the data, you can use the join. Right? Remember, we do the topic 1. You can combine these 2 tables using the join. You can get the table in the book, right? Because I have this table, right? I have n, then you join them, right? But I'm not going to do that. Right? The ID is industry, right? Industry can be in the method. You can do that part. That's really what we're doing, right? So we can see, right? Break them up by industry, right? Before we break them up by firm size, but we can also look at industry. In industry, look at in more detail, right? Which industry has more, which industry less, right? And then we know better how things done, right? Because we can, if it's a uniform, then it's not, right? And in statistics, or look at the economic side, this is called the heterogeneous effect. Usually, when you write a report, right, you will do the overall study, and so the trend, and then you can break down each subpart by grouping and see which industry or each group has different effect, right? Then we can target. Let's suppose you are doing, say, an IT study, right? You are saying that maybe the new things like Taobao is going to offer $99 free shipping to Hong Kong 2 days later, right? Then you will have data from the Taobao, maybe a month later, right? You want to study, well, is it going to increase the sales, right? And then you have a bunch of data, right? Before and after, right? And look at the increase, right? And then, so after, likely you will see increase in sales, right? And then you want to break down, say, by age group, right? Break down by gender, break down by district in Hong Kong, right? And see whether this will help, right? When we think people in Swiss table, they don't care, right? Because they can go to Shenzhen. Right? People like me from Hong Kong Island, they try to buy because I used to buy from JD. And now because of Taobao free, and I hope I will buy Taobao. And so it depends on who, right? And that would be the case. Is that clear what we're doing? So at the end of the day, let me the last line, right? It's we have covariance, right? We also see that that positive negative, right? Depends on you look at the graph or you want to look at the correlation matrix. So the next question is it causal, right? Because there's something wrong, right? I already hint that we can only do it at the very last 2 classes, right? But a short thing is, if we do experiment, yes, just like we have just said, Alibaba, Taobao actually impose this by themselves, they control, they do experiment style, right? They impose this new policy, right? Then yes, that's no problem, right? And that's causal, and then you can do that, right? But sometimes you don't. Okay, observation, right? And then you have to be a little bit more careful to look at data. Right? What we mean by observational? For example, we look at now the shipping discount, right? By Taobao. Just now, that is sudden change to the policy, that's okay, right? But if you look at data of the historical data, then you have to be a little bit more careful, right? because they suppose they in some time, right, Taobao give a shipping coupon, right, or Alibaba giving some special event, right? You may want to conclude that, okay, this shipping discount actually helps sales. So you want to study the problem whether giving shipping, reduction of shipping fee actually helps sales. But the problem is, it's unclear. Why? Because in those data, usually the shipping coupon is given in the special days, right? Like November 11 or 18th of June, right? These kind of special days, B.B.A, right? Those kind of days, or February 14th, right? Right? Those days are very special. People tend to be different. So if you do that, you have to control those days, right? Maybe you want to compare days, right? B.B.A or non-B.B.A, right? And have some different model, right? To isolate that, right? Or historical data to look at how different things works out, right? Even in the case we have Taobao data, right? Because the free shipping is going to impose on 1st of October, which is going to be the golden week, right? So the things are different. So you have to be very careful. Even this experiment is not that clear because we have to also look at other things in the background. So it's much more complicated. But at least we can say more, right? Okay. So then we're basically done with the lesson 1 and lesson 2. So just a quick summary what we have done so far, lesson 1 and 2. Lesson 1, we understand the data is very important, right? When you got the data right, then you get it right? Garbage in, garbage out. It's very important because compare different artificial intelligence model, ChatGPT model, right? And the data will make a lot of difference. Right? That's why you can see why Facebook give their AI algorithm for free, right? The Llama, right, is for free, right? And ChatGPT, right, is based on that, and then we know that the main thing is the data, right? The data itself, the training, AI is actually is the key part of the thing, right? And then we learn lesson 2, right? Look at the data, how to understand the data, look at summary statistics on the graph, right? Look at each column, look at the graph, look at the summary statistics, and see what's going on. Do we clean enough? Do we need to clean more or not? Do we need some group thing to understand what's going on? And then we just learn correlation, covariance, or the graphic. That's the way to see whether there's some pattern, right? And learn from data, right? Because data itself is very big, right? We want to study is the data can be understood by some trend or some pattern, right? Because we want to the pattern will generalize the data to be imposed into model, right? So that would be the goal. So the lesson 3, okay, this is the last lesson before we actually go to something, right? Because after lesson 3, right, if you still look at our syllabus, if you go to look at our syllabus, right, because we have studied so many details, probably you lost track of why we are doing all the crazy thing we have been doing, right? You look at syllabus again. What we're doing, right, is we learn how to clean the data, model the data, and then we done some preliminary analysis, right? And after that, the 4 and 5 is regression or prediction model, and then we have machine learning, and then we have some causality analysis, right? And lesson 3, or week 3, I suppose, is the slide behind, is saying that we will estimate a lot of model here, right? But we will learn how to use the model. The reason is being that the model tells you something. Say they're positive related or the coefficient positive, they give you the asset model. You have to know whether the model actually works or actually due to your data randomness. Right? You're not so sure whether the model tells you the right thing. You have to test, you have to say test the model. That is the idea of hypothesis testing, right? To make sure that the model, the result give us is robust, is useful. And journals and data means that we're trying to tell the procedure, and how we can use data to form a prediction, to form estimation, right? In general sense, right? Then we form the foundation of the rest. Okay? Of course, we are not that class, right? So basically just tell you some principle behind how we extend the result from data to general thing for estimation. And then other than that, then we have more fun, right? So far, it's very boring. I try to make it as fun as possible, but it's still boring. But other than that would be more fun because so far we just build the foundation, right? Because do remember that if data is bad, it's not going to be good, right? And what we've done in lesson 2 is trying to see, is there a pattern on data we can learn, right? If this is not, then you can't really go forward, right? Because you first establish there's some pattern you observe, and then you can do regression and do the thing, right? That's not going to be right and nothing to learn, right? Just like you go to a meeting for marriage, right? Something, right? So you go to something. Then supposed to go there, right? And if you don't like that guy or that girl, then it's not going to work, right? If you see his face, you don't like him or her, then it's not going to work, right? You have to understand what's going on before you can continue, right? So that's the idea, right? You have to understand whether it works or not. Okay, so that is the focus of the third topic, right? It's trying to see how we can extend the data to draw general conclusion, right? Just like we have seen is taking the forum is going to be have a better management, right? And but that is from historical data. Is it generalizable? What assumptions we need to make for this to be okay? And second is we use data to make decision, right? But what are the criteria to make decision, right? Just like in the courtroom and the murder case, okay? What kind of evidence you can conclude the defendant is guilty, right? At least the first thing is the guy is in the scene, right? And maybe he has a weapon in his hand, maybe a blood stain on his shirt, so and so forth, right? Maybe fingerprint or so and so forth, right? Maybe at least that guy, they know each other, they have some bad relationship before, so and so forth, right? There's a list of items to check before the data can tell us something is there, right? Do remember, we only look at part of the thing we observe. I look at data, right? Even the future can only be predicted by the past by some percentage. The change keep changing, right? Unless the future is identical to now. Otherwise, we have to make this decision. That means that we never 100% sure. We have to take a risky choice. Okay, right? You never know it's going to be good or bad, right? Go to marriage market, and before you say yes, right? At the marriage ceremony, right? You never know whether the other half is going to be bad or good, right? You just take a bet, right? Then we have to tell you how to make a bet. Okay. Let's a break of 15 minutes and then come back. We will continue our part. So let's have a second break item. And our break will be 11:39. 11:40. 11:40, then we will continue this. Let's a break of 15 minutes. 打住了。 也希望可以把技巧把这个科技小学。理解在应该还遇到的遇到问题，不会的话，AI 还是主要是那个。 Not working. So maybe we can try to look at your comment first. We have 28 of the reply. AC too cold. Can you turn down a bit? Okay, let's see. Is it too cold? I don't know because I didn't touch anything. So it's 21.5, maybe a little higher. We set it to 22.5. So hopefully that's not too cold. Because I'm walking around, so I'm not sure how cold it is because also the light is beaming, so it's hotter than you guys. Ah, good. Yeah, plotting and data. So I think now the speed is okay after the little bit. Yeah, overall it's fine, seems to be. So there's no joke. That's okay. Good. So I guess some of you who know Python will think I'm too slow. Some of you haven't mastered the Python will think it's too fast, but I hope I strike the balance in the two. I mean, hopefully, at least if you know very well, then still a good revision to what we have learned already. So as I said before the break, is we try to generalize the data. So basically, the thing is, if you look at this classical statistic, is called estimation. To estimate, and hypothesis. So let's go straight ahead to the thing we want to study. Okay. So what we want is, like what we have seen is, we have seen, say, the example, the case study we have is management score is increasing with the firm size. So the thing is it this pattern we observe is going to be generalizable? It's going to be whole in our data. So that is super important. The first thing to do is we will do inference. That is the actually main goal of the rest of the course, is to see how to generalize this, okay, which will be the subject of today. And second part is, which is a little bit more subtle, but actually it's more important, is it going to be true in general more than the thing we have? Okay. This is especially important, say, for example, you look at if you are finance, look at the algorithm trading or stock price prediction, right? Very often there you will see the algorithm or the trading system that works for based on the data doesn't work in the real world, right? Or look at the machine learning or the artificial intelligence, they look very well when they're data, but once you put it in practice, they die. And the reason is being that when you feed your data too well, there is overfitting, then will affect the external value, right? Because the features in the data actually is not featured in the population we want to study. Okay, then that's why when we still have machine learning method, we still want to use regression, because the regression don't use too much, a lot of feature in the data. So when you draw general conclusion, they're likely to be more robust. It's more likely to be external values, right? But when you try to use a lot of feature with advanced model, that turn out that maybe it fit very well in data, but doesn't do very well, good job with reality. So later you see the trade-off between basic model regression and sophisticated model of machine learning. Then there's some trade-off that you may decide what to use. Okay? Of course, that's why now these days people use AI is because of the data they're using is huge, several billion, trillion data set, then the problem may not be there, right? But when the data, when you try to do is not that sophisticated, then there will be some issues here. So it's not more advanced tools will be better. So of course you learn later when you learn the machine learning, you probably say, okay, I'm going to throw away all the regression, right? We throw away all the things you learn. Not necessarily, not so fast. If you have a rich set data, very rich, and then you think the data actually is representative, then fine. But if you think the data is just like a past snapshot and things actually changes, then you have to be very careful. Okay, so I hope, but we are not going to talk about this, but that turned out to be very important, right? And so estimation basically is we have a lot of things to do, but we focus on the simplest thing actually you do in undergrad, right? If we want the data, okay, say use the statistic from data to estimate the same thing in the population. What I mean is, say, suppose I have the data of one snapshot of today's trading or today's purchasing history of today's in the Taobao, say, right? And then I want to predict what happened next week, right? Then it's using the sample mean, right, of today to estimate the population mean, right? That form of prediction, right? Just to do it graphically, what it means is the following, okay? Generally, that's what we are doing, okay? Suppose we're interested in population is something we were interested in. That's what we said, right? So suppose I want to know, say, maybe next week is what we call the Golden Week, right? Right? And you are managing the IT manager of the, say, Alibaba or JD, right? Or Taobao, right? Then you have to decide how much the bandwidth to do it, right? Because you have to increase it, right? The calculation, right? Use more computer there, right? More costly, but you have to operate it. Then you want to estimate that part, you don't know, right? So that will be the population. We have something, right? There's some distribution here, right? And then, right? They want to estimate the mean of this. You want to know this meal, right? The bell curve, something like you want to estimate that part. You don't know that. How can you estimate this part, right? What you're going to do is look at the past data, right? Which is part of it, right? Part of that, this data. The data, right? From the data, what you use is likely sample mean, right? And use sample mean to guess the meal. Right? So this is for estimation, right? You get some data to estimate what's going on. Right? There's the sample mean, right? And also you also want to know, assuming the data is normal, then besides the mean, and you also want to know the standard deviation, right? And probably you learn undergrad as well is here, you come with the standard, so you come with sample variance, then estimate this guy, right? So if you assume the underlying is normal, then that is you're done. You can do a lot of things, right? Once you have this and that, the bell curve that tells you if you want to be 90% sure, then you would provide here, like the 10%. This is how we learn, right? Nothing deep there, right? But since we're doing data, so we'll probably just leave it there, right? Because we're not going to go to that deep, but that will be the goal as we do. Okay. Is that okay? I mean, this is something you learn in undergrad, but I just try to do that, right? So you pick sample mean, sample variance. Okay. The thing you just is on estimate, right? But you also learn undergrad. It's not estimate point. You can also estimate interval, right? That is the two things we're doing today, right? why we do that, okay? Why we care about this thing is this is the technique that actually use not just care about these two numbers, right? Because at the end, what we've seen there, what we've seen in here actually we have a simple model, assuming this is Solomon norm, a simple model. But at the end of the day, actually we have a complicated model, like regression model and machine learning model. We have to estimate this problem, right? Regression is a line. Line is characterized by its intercept slope, right? If you have a tree, then you also have a similar thing, a different parameter to split the tree, right? Or you have many ways, then you have some number there to have a model, right? The model is a number, right? You have to guess those numbers there, right? So that estimation is needed because I want to use this number to think what's going on here, right? No matter regression model, which model is actually assuming how the population looks like, right? Machine learning is just like very complicated model. You assume the population is a very complicated thing, right? This number controls different part of the model, but use the data to guess those numbers. Okay, and the hypothesis testing, which we will do next week, is to make sure that what we found is very. So that's why this class is very crucial in terms of the notional thing we're doing. Okay, so let's go back to here. So then that's why we're doing this. No matter you do a simple thing or very complicated model, this is what we need. So that's why we're to understand what's going on here. So we're abstract. So let's go to an example, which some of you may care, is investment. Okay, and now we know the Hong Kong stock market and Shanghai stock market is now skyrocketed. So the question might be you would ask is, should I go in, right? Then, of course, I'm an economist, right? I also teach finance, right? Then the question is, well, the first thing to do is look at the risk, right? Because the first principle of finance is risk and return, right? There's no free lunch, right? When you go in, maybe go up a lot, but there's a lot of risk. So calculate the risk is one thing is look at how likely that you get 5% loss, right? It's very simple thing. It's like how likely you lose 5% a day, right? Because stock market is good thing is you can always go out, right? Quickly, right? So if you lost 5%, maybe you can out, right? You want to bye-bye, not going to take the risk. So what we do is look at the US stock market, but you can use the A share or whatever you like. It's the data. They have daily data of 11 year and start from 2006 up to 2016. So you can see the way I write, right, is very usual way you should write your report as well. Describe your data, right, similar manner. Okay. Now I think I need not explain this one, except the third line. First numpy and it's okay. The third line is what later you use is I use the science Python package. The sublime statistics, I will do a normal distribution. Later you see why I do that because I do t-test. Later you see why I do that because the bell curve will not normal. So this is the part that we are doing, but other lines it should be clear. If not, then you should check back our slide. Okay. So we have chapter 5 here. Chapter 5. So this is the code. Then we download data. And of course, the first thing to do to look at data a little bit because right, we can just type stop or stock head. Then you will tell you what are they, right? Turn out to be this data is very simple. Only have 2 columns, date and value. By construction, the value would be the stock because SP 500 is the stock market index. There's no trading volume. There's no other thing but just the standard price time series price data. One value over time. Okay. And when you have time series data usually with the clean first because a lot of technicality here because first is there may be missing value for say weekend, right? Or there may be some missing value for public holiday, which is not there. Okay? Or there's some collection problem. Okay, when you have time series like this. Okay, and as IT manager, you will also often have this kind of missing data. So again, how do we do that? It's pretty tedious. First, I have data. I will replace any nothing by NA. I also replace that is NA by NA, and I drop it. Okay, and sometimes you have to be careful because sometimes the NA can be say -1. That's your NA. So suppose the price data. Sometimes the system will record the -1, the NA, or -999 NA. So you have to check your data carefully. Okay, but I'm not going to do it here. So drop NA. Then the last line probably asks why I do that, right? Because the data is indexed by 1 up to say how many data you have, right? But once you drop the data, then there's some missing there. Right, there's not no longer one. There's some missing number. So you drop the index to make the number start from 1 consecutive. There's no missing number. Is it important? Yeah, not so. Just do it. Okay. Why we do that? Because we need to calculate return. But let's do the first step first. Okay. This is cleaning the data, and okay, so basically you clean this up. So there's nothing new if you try to run this thing, is the same thing. You clean it up. Nothing new there. So you can see this is only 2,500 row, right? But before you have 2,611. So number of rows is reduced. So it's doing something, right? So that's to check carefully what you're doing. Is that okay? Just I take some 10 seconds off. Take yours. Copy. And the reset index is useful because you will see the last row. The original index is 2610, right? But now after I do that is 2518. So you can try if I don't do this, what happened? So if you don't do this, you can see this number are not matching, right? Because it's still there. So that's why I have to do the drop. So hopefully it makes sense why you want to do that. All right, so that's why I want to do the drop index. For it's clear why I do that. Now, once I have that, the next thing to do is I want to check out the data, how many days I lost 5%, right? So this is price data, right? So I want to calculate the return, daily return in finance. That is look at today's price minus yesterday's price. That's loss and gain in absolute term. Then I divide it by yesterday's price. That is the percentage change, right? Gain and loss percentage. So in Python, or sorry, so the Panda, there's a very convenient thing. We don't need to take today's minus the day over this day. Is what we call dot percentage change. Automatically get you that number. Okay. And I multiply 100 because I want percentage. Okay. You don't have to get 100, but that is going to give you, this is going to give the percent, right? So then if you like, you can look at the return. Okay. Of course, the first day has no return, right? Because the first day can go back. Right? But otherwise, you have all data here. Okay. Now, once of this, because this is the only thing we care, right? The price by itself, we don't care that much, right? But the return is the thing we care. We want to invest in the US stock market, according to the case study, right? So what we want to know is plot a histogram, which I'm not going to do it, but you can do it, right? You can plot a histogram, and you can check out from the graph how many days less than 5%, right? I think you have to know how to draw this histogram, right? You learn, if you have time, you can how to draw it, right? Plot this, right? Sorry, I'm not going to do that, but that's going to be difficulty for you to draw this, and then figure out that less than 5% is not a lot, right? Basically nothing. So in the US stock market, pretty safe. And okay, the question is, well, is it going to be generalizable, right? Is this thing, is it that safe, right? It's very little days that I should have this. The question is this graph going to be hold true for the future? It's going to pass, right? How can we answer this question? The question lies the idea that, okay, we only observe the history once, right? The stock market is not going to run many times for us. How can we make sure that the future is going to follow the same, right? The idea is you can think in theory, we can collect this many times, right? In theory, let's think about this. We can generate this data many of them. Okay? Just think an experiment, a thought experiment, think about we repeat this. Okay? And we're trying to think whether the procedure we did, which is sample mean and sample variance, is actually we use the sample mean or some calculation of data. Okay? The procedure we do, or draw the graph, we repeat this for every single data we can do, we can generate. Okay? And we try to see if the procedure we do is going to be good. Right? So what do you mean that is with the sample mean and sample variance, right? And this particular number we get, right? Notice how good they are is imagine that we can have many samples. Then we can have many sample mean and many sample variance. What we get is one of them, right? And the question is, okay, can we get how accurate they are? Okay. How do we do that? Okay, there are many ways to do it. Okay, the first way is to do simulation. Okay, let me explain it in more detail for this example. Okay. The example is turned out to be, look at the data, the graph as well. Only less than 5.5% of days actually have that. Okay, that means that out of 1,000 days, okay, only 5 days lost more than 5%, right? Over for 3 years of time, right? So that is pretty much safe, right? So how can we generalize this? As that we can't really have the history repeat itself of the computer. Okay? We can have a computer to mimic the history generation. And let the computer generate many possible history, right? And then all the history we have is calculate how many days that more than 5% loss. Then that will tell us the risk. Let me repeat what we're doing, okay? We only have one history. We can calculate this number, the days are more than 5%, right? But that is one history. How likely we believe that history is going to be there? What we do is use the computer to generate many histories. That is what we call simulation method. And if you learn classical statistics undergrad, then you never learn it. But now, because of computers so fast these days, this becomes available. Right? Because in the old days, I think during the time 20 years ago when I was an undergrad, computers still very expensive. Do simulations is very costly. But now, even your cell phone can do it quickly. So now, when you learn statistics, then these days people tend to do more simulation rather than doing the classical calculation of normal thing. Assume some bell curve because this probability cannot do. Doesn't follow normal. You can't really use the bell curve idea. Okay? But you can regenerate history and do whatever you want to calculate, right? Because it's 5%, I change to 10%, change to 4%, change to whatever percent, whatever you think you care, you can repeat the history. So this method is universal. Let me give you more detail to give you more concrete understanding. So what to do? What actually this graph is doing, which we will do, we show the code. So they have 10, 11 data, right? How they're going to do that is, okay, they would randomly pick 90 days. Okay. And these 90 days, you can calculate how many percentage of days that you have more than 5% of. And you do it for 10,000 data. Okay. So you create world, actually not just one world, you create 10,000 worlds. In each world, have 900 days training data. And you calculate how many daily loss of that. You plot the histogram like this, and you find the mean. Okay. Then this is how this looks like, right? And it looks like, okay, of course the mean is here, right? But you can see how left and right looks like, right? Actually, it's like skewed a little bit here, right? So this is maybe too optimistic, right? You could be maybe expecting more than 1% of the, right? Can go as high as this. So it's not 0.5%. Can actually go to 1%. Not so rare, maybe 0.75% maybe. Right? So you can see how accurate is this. Of course, if you're lucky, it's very close to this one, then that's good. Right? But sometimes it can be less spread out. Okay, so that is how you can see whether this guess is a good guess or not so good. Right? If this is basically collapse to the center, so your confidence that this is a good guess. So that is how you can do it, because now simulation can tell you a lot. Okay, and here they tell you two different kinds of simulation. Is the blue one is you every time you have 500, each world you have 500 days. Okay, as opposed if you have each day, each world have 1,000 days. Okay, and we have more, of course, more costly, but you're getting more accurate. So it's not as bad as before, right? Or probably you get more, then you more likely to collapse, right? Because you get more accurate. That guy, right? So that would tells you how risky how accurate number you get, right? Because what you get is 0.5 is here, right? I tell you that actually maybe other universe you get maybe somewhere here. So it's very important to look at this kind of graph, okay, which we'll formalize later. But this is just graphically show you how you can do that. Okay, is that clear what we're doing, right? Because the data you get, the number you get from data, okay, may be good enough or bad enough. It's how good it is something we want to ask. How good is what we get, right? How can you generalize this? Is how believable you can do, right? But the fact that we don't observe another history, right? We don't observe what we have in this universe. We don't observe the other universe. Then how can you do it? Let the computer generate other universe for us. Okay? And when generate different universe, you repeat your process. You know that what we do is you do the same process in the same different universe. And this tells us how variation of how accurate it is. If this is going to be spread out, then you have no confidence of what you get. If that is okay, then you will much better, right? Then you want to quantify this is what we call the confidence interval, which we will talk immediately now, right? So also you learn this in undergrad as well. It's the common, right? Usually what you learn is if it's a bell curve, it will be later you will see the slide as well. It's 2 SE, right? 2 standard error from that bell curve. Right? 2 active scientific. You learn that in undergrad, right? But that will be the 95% confidence. And what here is said, we would say a confidence interval, not probability interval, is because the terminology, because I don't want to explain that. The idea is the following. That is the idea. Probability is something that only can be assigned to things hasn't happened. Okay. For example, I toss a coin. Okay. Before I toss it, I can say probability. Right. But if I toss it and I hide from you, okay, then you cannot say probability. Because it's either head or tail. There's no probability here. Right? So that's why classically they don't say probability. They say confidence. But that is because the old way people are saying probability. But if you're Bayesian, then you can still say probability, right? You still can say 1/2 is head, 1/2 is tail. So, and how should we understand this confidence interval? Is the idea that we have just said. Imagine you have many universes, right? And 95% interval means we construct 100 universes. Okay. And 95 of them, the interval, right? That's all that. The 95 interval means that in 100 of universe, okay, and if you repeat your process in this 100 universe, 95 of them, okay, will include the right thing. Okay, so let me repeat what I said. Okay, so let me draw it. Maybe a little bit sorry, a little bit tricky. Maybe I shouldn't talk about this technical thing. So what I'm saying is you have this, right? The confidence interval means that I would not just this number, but I will go left and right by 2 standard error, which probably you have learned in the undergrad. Right? What it means is if I repeat myself in 100 universe, there will be 95 of 100 of this. Right? 95% means that 95 of them will likely to include this guy. Okay? But you only do one of them, so you don't know which one. And that's why I cannot say probability. Okay? Because hypothetically, you fail, you repeat this 100 times, but you never repeat, so that is the I'm sorry to talk about it is super technical or philosophical problem. Maybe I should put it in the technical slide. Okay. So that's what you learn. If for the sample mean, I can do it. Right? But if not sample mean, then how can I do it? Right? Sometimes it's very difficult. So that's why there's a limitation based on the theory. But we will do what we learn is somewhat we have just seen, we sample it. Or we do bootstrapping. And bootstrapping is the thing that these days people use way often. Because formula means usually the bell curve, the F distribution, the chi-square, the Poisson, whatever distribution, or gamma, that's something that's a condition. But there's a limitation to what you can do. Okay? But there are many measures that you are interested in has no formula defined. So what you can do is go back to simulation, look at data, and create a history by yourself, and look at this how it works out. Okay. So okay, let me talk about these two slides, okay, quickly. So I have NumPy and science Python, I want to step ST, and I have data here. I generate the standard deviation data. I can actually, it's good that they can do the standard error. Okay. Standard error is when you estimate interval, it's how big is that? Calculate that. And why it's good? Because when you care about sample mean, which usually care by and essentially the or large number will tell you this sample mean will approach to the population mean and these ranges. And that's why the standard error can be estimated for this one. Okay. And that's why when you estimate what you care about sample mean, which is always you do when you calculate the model, right? When you have all the model, whatever you think, you have to do this and plus minus 2SE. Okay. And that would be the goal, right? So in this case, right, number of days need is 5%. You can calculate the standard error, standard deviation by standard calculation. And then you can calculate SE, and then you can also calculate the why is the case. Because this is there's a math behind this because the binary data. So it's proportion data. So the proportion data, the mean and the variance of data, because it's P, this is P times 1 minus the square root. I don't want to go into detail because this involves statistics. But just trust me, this is going to work. And the reason why we do this is to tell you that's the way you do it. If you learn undergrad, that's okay. If you don't learn undergrad, then it will be difficult. But I don't want to go to detail on this one. Because of the time. I'm sorry that this little bit more difficult than we do because this is what I teach in undergrad. But I can upload the slide for the undergrad. So that is actually when I teach undergrad, that is basically related to the when to estimation. They have something like when you estimate the estimate proportion, that is how we do estimate. Something like that. But I don't want to bother you with the undergraduate stuff. But when you have the data, it's like the proportion data. That you how you can calculate. But that's the theory how to do calculation. Okay. So but the main thing later you will see, I don't want to take more time, but the main thing for our class is do sampling. Do this sampling and do this bootstrapping. Okay. But probably what is important is this one. Okay. And the p-value 5% is actually for. Okay. But I don't want to keep you here. So enjoy the weekend and have fun in the holidays next week, right? Next Tuesday is a holiday, so have fun, enjoy, and I will see you next week. So stay around to answer any question you might have.